Well, here we are with mechanics videos, springs and masses. So I've got here 3 springs. These 2 springs are the same springs, but they've got different masses hanging on them, and here I've got a different spring. So if I set this one into motion, it describes what we call simple harmonic motion, and you'll be analysing this shortly. And we'll be focusing on the period, which is the time for one complete oscillation. So that's a simple spring and a mass. Now what I'm going to do now is to set in motion this one over here, which has a much greater mass, and you can see that the way that it moves is different. So changing the mass is an important factor in this. Also, I can change the spring. So with this very big spring here, I can set that in motion, and again we see a different type of motion. So the work that you're going to do is to be able to find the period, predict the period, and that will depend on the nature of the spring and of the mass that's attached to it. So we're going to focus on this one. Let's get rid of that for a minute. Put that one out of the way. So the first thing you need to do is to calculate the stiffness of the spring. So I'm going to look at this spring here, and the natural length of that spring is about 2.2 centimeters, and I'm now going to hang on a 300 gram mass. And the extension of that spring is now about 14.4 centimeters. So calculate from that the stiffness of the spring, and then you can do the maths and work out the period of oscillation. So assuming that you've all done that very quickly, I'm now going to set this into motion, and what I want you to do is to count the time for 10 oscillations and then work out the period from that and compare it with your prediction. So here goes.